we need to find sum of coefficients of integral powers of x in this binomial expansion 1 minus 2 root x whole power 50. Integral powers of x means we are looking for powers of x power 1, x power 2, x power 3, etc. These kind of powers of x. We have root x right here. Root x power any even number. Any even number will give integral powers of x. For example, root x power 2, 4, 6, and dot 6, 8. These cases are fine. But root x power 3, 5, 7, these are not really that we are looking for. Because then it will not be integral power of x. So this expansion 1 minus 2 root x, we can write it as 1 plus minus 2 root x whole power 50. What is the general expansion? General expansion is 1 again minus 50c1 2 root x, right? So because this is minus 2 root x whole power 1, right? So we are bringing that minus outside, right? Then plus 50c2 again 2 root x whole square, that is 2 square x 2 square x minus 50c3 2 cube 2 cube root x whole cube plus 50c4 2 power 4 root x whole power 4. Similarly, minus 50c5 2 power 5 root x whole power 5. Like this. So this is root x whole square, right? This is also root x whole square, right? Like this. Now we are looking for all these terms, all the integral powers of x. That is, this is also integral power of x, right? X power 0. This we can read it as x power 0. So we are looking for all these terms. 1 plus 2 square into 50c2, and this one is not integral power. So this one, wherever NCR, wherever R is even number, right? Plus 2 power 4, 50c4. We are looking for these cases. Plus 2 power 6, 50c6, so on, so on, so on, until 2 power 50, 50c50. Right. This is the sum of coefficients that we are looking for. Right. 1 plus 2 square into 50c2, 2 power 4 into 50c4, etc. etc. This is the sum that we are looking for. But now, how do we express this in terms of 3 power 50, 2 power 50, whatever, whatever? Okay. Now we can see we need to express this in terms of either 3 or 2 or something. Okay. Now let us do something. 1 plus 2, we are looking for this one, right? Now, 1 plus 2 whole power 50. What is 1 plus 2 whole power 50? 1 plus 50c1 into 2 plus 50c2 into 2 square plus 50c3 into 2 cube, etc. etc. Similarly, what is 1 minus 2 whole power 50? This is again 1 minus, well, this is equal to 1 plus minus 2, right? So that's why 1 minus 50c1 into 2 plus 50c2 into 2 square minus 50c3 into 2 cube, etc. etc. Now, if we add both of this, what is this? This is 3 power 50 and this is minus 1 power 50, which is equal to 1. This should be equal to 2 times of this, and this will get cancelled. This and this will get cancelled. Only even powers will be left, right? Which is what we are looking for. So we'll be left with 2 times of 1 plus 50c2 into 2 square, that is this one, plus 50c4 into 2 power 4, etc., etc., which is exactly the same summation that we are looking for. Basically, to get the summation, what we are doing, we are trying to add 1 plus 2 whole power 50 and 1 minus 2 whole power 50, right? So to remove all this 2 into 50c power 1, 50c1, 3 into 50c, 2 cube into 50c3, etc., 2 power 5 into 50c5, this kind of odd r's. When r is odd, we want to eliminate these r's. We want to keep only r's which are even, right? When in NCR 50CR, we want to keep r which are only even. So that's why when we do this, all these odd r's, this 1, 3, 5, and all, they will get cancelled, and we will be left with 2 into 1 plus again 2 square 50c2, 2 power 4 50c4, etc. etc. Now, what will this sum will be? It should be sum of this by 2. 3 power 50, that is 2 plus 1, 3 power 50 plus 1 minus 2, minus 1 whole power 50, which is again anyway 1. So 3 power 50 plus 1 by 2. So that is the correct answer. Right, guys? So firstly, we should be able to find out what exactly are the coefficients. That is the first step. Then how do we express these coefficients in terms of 3s and 2s? That is the second step. Right, guys? Hope you like this. Thank you.